Welcome back. You're now going to learn about Amazon EC2 Autoscaling. Amazon EC2 Autoscaling helps you maintain application availability. It enables you to automatically add or remove EC2 instances according to various conditions you define. For example, you could configure Amazon EC2 Autoscaling to terminate EC2 instances that fail health checks, and then to launch new instances to replace them. And you can create user-defined policies that use Amazon CloudWatch to trigger when to add or remove EC2 instances based on conditions like the average CPU utilization of your EC2 fleet. If the load changes are predictable, you could set a schedule to help bring resources online ahead of time. And you can specify allowable fluctuations for the scaling activities within windows that you define. The main overall advantage is to be able to automatically scale out to meet demand and to scale in again to reduce costs when demand is lower. The process for configuring Amazon EC2 Autoscaling involves first creating a launch configuration before the actual autoscaling group is created. To create the launch configuration, you specify roles through AWS Identity and Access Management, or IAM. You also specify the security groups, storage, instance type, user data, key pairs, and so on. These requirements are similar to launching an EC2 instance, but you don't specify a VPC or subnet for the instances. This information will come from the autoscaling group itself. You must pay careful attention to one particular configuration option in the launch configuration, which is whether to automatically assign a public IP address to each new instance. But you don't need to select this option if your instance will be launched in a private subnet behind a public load balancer, for example. There are two main ways to trigger changes to an autoscaling group. First, you could define a scaling policy that's either going to scale out or scale in based on a CloudWatch alarm. Then you define a CloudWatch alarm, like the average CPU utilization is greater than 50% for 2 minutes, and then have the alarm call the autoscaling policy. The policy will then specify one of two options, like adding or removing a fixed number of instances, or adjusting the number of instances as a percentage of the desired capacity for the group. Second, you can define a scheduled action. A scheduled action sets a new desired capacity value at a specific time. You can specify it to trigger on a specific date and time, or to recur at specific times during a week, a month, or a year. This can be a good way to pre-warm capacity in response to anticipated traffic spikes like sales, year-end processing, or any predictable workload spikes. Amazon EC2 Autoscaling tracks the health state of instances and can then terminate instances that are marked as unhealthy. You could use it to help ensure that the instances in the group are functioning properly. By default, Amazon EC2 Autoscaling uses EC2 instance status checks. If an autoscaling group is behind a load balancer, either the load balancer's instant checks or the Amazon EC2 instance checks are used for health monitoring. But you could use external scripts to trigger recycling of an instance at any time by invoking the AWS Autoscaling set instance health command. If you want more information about instance status checks, search for monitoring system status checks in the AWS documentation. With each autoscaling group, you control when it adds instances to your architecture, which is called scaling out. You also control when it removes instances from your architecture, which is called scaling in. You can scale the size of your group manually by attaching and detaching instances, or you can automate the process by using a scaling policy. There is something called a default termination policy, which is designed to help ensure that the instances span availability zones evenly for high availability. And the default termination policy is typically sufficient for most situations. But you can replace the default policy with a customized one. For example, you could define a custom termination policy to decide which instances to terminate first during a scale-in event. You can use the Amazon EC2 Autoscaling API, terminate instance in autoscaling group action to terminate a particular instance and to decrease the desired group size. For example, you might choose to always terminate the instance with the fewest user sessions. After you've determined the instance ID, the terminate instance in autoscaling group can be called, and the instance ID can be passed in as a parameter. For more information about this, search for autoscale instance termination in the AWS documentation. You can customize the termination policy so that if one availability zone has more instances than the other availability zones in the group, Amazon EC2 Autoscaling applies your termination policy to the instances from the imbalanced availability zone. If the availability zones used by the group are balanced, then Amazon EC2 Autoscaling applies the termination policy across all of the availability zones in the group. There are 4 different types of custom termination policy. The first one terminates either the oldest or newest instances in the group. You might want to terminate the oldest instances if you're upgrading the instances to a new EC2 instance type, for example. Or you might terminate the newest instance in the group when you're testing a new launch configuration but don't want to keep it in production. You could also terminate instances with the oldest launch configuration. You might do this if you are updating a group and phasing out the instances from a previous configuration. Last, you can have a policy that terminates instances that are closest to the next billing hour. This is a good way to maximize the use of your instances and help manage your EC2 usage costs. It's also worth being aware of Amazon EC2 Autoscaling health checks because you could create a steady state group that helps ensure that a single instance is always running by replacing it if required. This can be useful if you have a network address translation or NAT server and you do not want it to be a single point of failure in a standard public-private subnet architecture. You can also scale based on a schedule in response to predictable load changes, as seen here. For example, you notice that every week the traffic to your web application starts to increase on Wednesday. Traffic stays high on Thursday and then starts to decrease on Friday. You will soon learn the steps to configure an auto-scaling group based on a schedule. You can configure automatic scaling to be dynamic. For example, you have a web application that currently runs on 3 instances. You don't want the CPU utilization of the auto-scaling group to exceed 70% for more than 2 minutes. You can configure the auto-scaling group to scale automatically to meet this need. Here's a look at how the policy type determines how the scaling action is performed. Amazon EC2 Autoscaling supports 3 types of scaling policies. First, you can use target tracking scaling, which increases or decreases the current capacity of the group based on a target value of your chosen metric. For example, aim to keep group CPU average at 65%. Next, you can have step scaling. Step scaling increases or decreases the current capacity of the group based on a set of tiered scaling adjustments, which are known as step adjustments. And finally, simple scaling increases or decreases current capacity of the group based on a single scaling adjustment. You also have predictive scaling. Predictive scaling uses machine learning models to predict your expected traffic and Amazon EC2 usage, including daily and weekly patterns. It uses data collected from your actual EC2 usage and data points that are drawn from our own observations. The model itself needs historical data from at least 1 day to start making predictions, and it's re-evaluated every 24 hours to create a forecast for the next 48 hours. Here are some key points to consider. First, predictive scaling predicts future traffic based on daily and weekly trends, including regularly occurring spikes, so that it can provision the predicted number of EC2 instances before anticipated changes. It also reduces the need to manually adjust Amazon EC2 autoscaling parameters over time, which helps make Amazon EC2 autoscaling simpler to configure and consume as a user. Be aware it appears under the AWS autoscaling page in the management console, not the EC2 area. So to get started, you navigate to the AWS autoscaling page and create a scaling plan for EC2 resources that includes predictive scaling. After it's enabled, you can visualize the forecasted traffic and the generated scaling actions. You can combine predictive scaling alongside dynamic scaling. Keep in mind that it works by forecasting load and scheduling a minimum capacity, but dynamic scaling uses target tracking to adjust resources that help keep a designated CloudWatch metric to a specific target. Ultimately, the 2 models can work well together because the scheduled minimum capacity is already set by predictive scaling. In conclusion, predictive scaling is a good choice for websites and applications that typically experience periodic traffic spikes. It's not really designed to help in situations where spikes in the load are not cyclic or predictable. You'll now learn about avoiding thrashing. When there is excessive use of a computer's virtual memory, the computer cannot service the resource needs of running applications, and the condition is known as thrashing. It's a good analog to when instances are removed and added, or added and removed in too quick of a succession because of automatic scaling. One way to avoid thrashing is to trigger alarm actions for actual sustained state changes only. That is, for state changes that have been maintained for a reasonable period of time. It's helpful to know the Amazon EC2 autoscaling cooldown period setting because it helps ensure that autoscaling doesn't launch or terminate instances before the previous scaling activity takes effect. When you manually scale your autoscaling group, the default option is to not wait for the cooldown period, but you can override the default option and observe the cooldown period. Likewise, if an instance becomes unhealthy, Amazon EC2 autoscaling doesn't wait for the cooldown period to complete before it replaces the unhealthy instance. Amazon EC2 autoscaling supports default cooldown periods and scaling-specific cooldown periods. However, remember that cooldown periods are supported when you use simple scaling policies, but not when you use target tracking policies, step scaling policies, or scheduled scaling. You can also specify the number of seconds it takes for a newly launched instance to warm up. An instance is not counted towards the aggregated metrics of the group until its specified warm-up time is expired. When scaling out, AWS does not consider instances that are warming up as a part of the current capacity of the group, so multiple alarm breaches that fall in the range of the same step adjustment only result in a single scaling activity. This helps ensure that Amazon EC2 autoscaling doesn't add more instances than you need. Also remember that in some cases, you might want to perform an action manually before automatic scaling takes place. Lifecycle hooks give you this flexibility. Here are some examples of scale out and scale in sequences. Look at the scale out example first. Here, Amazon EC2 autoscaling launches an instance, sends a pre-configured notification to a person or application. It then takes no further action because the user or script must install any software and then add the instance to the group. In the scale in example, the Amazon EC2 autoscaling lifecycle hook removes an instance from the group and then sends a notification. Now, when the user or programmed action receives the notification, it performs an action on the instance before it terminates the instance. A good example might be retrieving the instance's logs. If you want more information about the Amazon EC2 autoscaling lifecycle, search for Autoscaling Group Lifecycle in the AWS documentation. Thanks for watching. See you in the next video.